Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department, IIT Kharagpur. I welcome you all to this lecture 5 which will be related to the tutorial. Whatever concepts we have covered in lecture 1 to lecture 4, that I will try to further clarify with the help of using these problems. So the concepts which we have covered so far is sleep, rolling radius, how to measure rolling radius, how to measure motion resistance ratio, then what is net traction ratio, gross traction ratio, then tractive efficiency and power delivery efficiency. All these parameters I am going to give you using these questions. The first question is find the distance covered by a 500 by 65 R22.5 tire when it makes 10 revolutions in 2 minutes on a hard horizontal surface with the tire deflection del by H as 20%. So if wheel slip is 15%, then find out the actual distance covered. So here the concept what we have done for measuring the diameter of the wheel, when the specification of the wheel is given, that will be utilized. Then how to find out the rolling radius, then how to measure, how to find out slip. These are the 3 concepts which will be tested here. When I said 500 by 65 R22.5, that means this is a radial tire and 500 is the section width. Which is your B. So this is 500 millimeter. Now 65, the aspect ratio is your 65. Aspect ratio, which is nothing but H by B, is 65%. So I can write as 0.65. Now nominal rim diameter. (22.5 inches). That means 22.5 into 2.54. That will give you in centimeter. Now to find out the diameter of the wheel without deflection, dia of the wheel without deflection. So this will be equal to, the formula is 1.06 times the nominal rim diameter, which is 22.5 into 2.54 plus 0.65 into 500 into 2. 500 is millimeter, so rather I should write in centimeter. So 50 into 2. So this will give you around 125.579 centimeter. This is the diameter. But in the question it is given that there is a deflection by 20%. So how to find out the static loaded radius, that is important. So 20%. So H was how much? So if I write here, H will be equal to 0.65 into 50. So 20% of that, 0.2. So that becomes a deflection. I think I should not write here. This is the H value. Now delta will be 0.2 times 0.65 into 50. So this will be your delta. So now static loaded radius. This will be equal to R minus delta. If dia of wheel without deflection is this, so R will be D by 2 minus delta. So R will be 125.579 by 2 minus delta. Delta is this value. Okay. So you'll get the static loaded radius. Now in 10 revolutions, how much distance it is covering? That we have to find out. So distance covered in 10 revolution. Two pi into the static loaded radius R minus delta into 10. Now if you look at the slip definition, so slip definition says slip is equal to distance traveled per revolution without load minus distance traveled per revolution with load divided by distance traveled per revolution without load. So the distance which you are getting here is the distance without load. So 10 revolutions you are getting this much. In one revolution just divided by 10. So that you will get around 35.367. So distance without revolution load will be around 35.367. This is in centimeter. Sorry, this is in meter. Now slip is given as 15%. So if I write slip is nothing but 1 minus VA by VT. So better write slip directly. Slip is equal to, slip is this much. So slip is 0.15. That is equal to this. Now this value is known. So this value is to be calculated. So distance per revolution with load will be equal to 1 minus this into distance traveled without load. So that will give you 0.85 times this thing. So that will give you distance traveled with load per revolution. Now for 10 revolutions, you just multiply with this value with 10. So that will give you the total distance covered. A two-wheel drive tractor which is weighing 2400 kg with a weight distribution of 35% and 65% of the total weight at the front and the rear axle. If rolling resistance of each of the wheel is equal to 4% of the total weight coming on it, calculate the force required to tow the tractor on a horizontal hard surface. That means we have to find out the rolling resistance. So in a tractor there are 4 wheels. So each one will contribute some rolling resistance. Assuming that the 2 rear wheels and the 2 front wheels, they contribute equal rolling resistance. So first you have to calculate the rolling resistance for the rear wheel. Then you have to calculate rolling resistance for the front wheel, and then summation of these will. So if you are calculating rolling resistance of one of the rear wheels, then what you have to do is the weight which is coming. Now 2400 is kg is the total weight. Out of 35% is on the front axle. So 35.35 into 2400 divided by 2. So that will give you weight coming on. So this is front wheel, sorry. Weight coming on the front wheel, each of the front wheels. Similarly, weight coming on each of the rear wheels will be equal to 2400 into 0.65 by 2. Now, coefficient rolling resistance is equal to 4% of the total weight. So, whatever value you are getting here, multiplied with 4 by 100, that will give you rolling resistance of each of the wheels of the rear axle. Okay. So, then you multiply with 2, so that will give you total rolling resistance for the rear axle. Now, similarly, you find out total rolling resistance for front axle. So, in that case, whatever value you are getting here, 0.35 into 2400 divided by 2 into 4 by 100 into 2. The summation of these two values will give you the total rolling resistance, and that will be equal to the force required to tow the tractor. So, that value will be equal to the force required to tow the tractor. So, here the concept of finding out rolling resistance is given. Now, the next question is, if the same tractor is used to pull a 3-watt moldboard plow weighing 250 kg, so there is a weight transfer, that is 2% of the weight is coming from the front axle and 10% of the total weight of the implement is coming on the rear axle. So, there will be weight, suppose this is a tractor, and implement is attached here. So, because of when we engage the implement, there will be weight transfer to this, there will be weight transfer to this. So, this weight transfer is 2% of the weight coming on the front axle. So, we have already calculated the weight coming on the front axle, which is nothing but 2400 into 0.35. This is the weight coming on the front axle. So, 2% of that. So, that will be transferred to the rear axle. Now, and 10% of the total weight of the implement. So, implement weight is given as 250 kg. So, 10% of that will be transferred to the rear axle. So, this one from the front transferred, this one from the implement transferred. Now, weight on the rear axle is already there, which is nothing but weight on the rear axle is 2400 into 0.65. So, summation of these three will give you the dynamic weight coming on the rear axle. Okay. So, once you know the dynamic weight, then rolling resistance is given, that is 4% of the weight coming, 4% of the weight coming on the weight coming on the wheel. So, you find out the rolling resistance. So, here I have calculated the dynamic weight. So, dynamic weight divided by 2, assuming that both the wheels are experiencing the same rolling resistance. So, this divided by 2 will give you the weight, dynamic weight of each of the wheel fitted to the rear. Now, 4% of that will give you the rolling resistance. So, 4% of the weight which is coming here, so WD single and rear wheel. Now, 4% of that is the rolling resistance, and coefficient of rolling resistance will be rolling resistance divided by dynamic weight. So, that way you find out coefficient of rolling resistance. So, here the concept is how to find out coefficient of rolling resistance. As I said, if it is a single wheel, there will be no weight transfer. So, here the weight transfer plays a bigger role, so that the initial weight doesn't remain constant, it changes. So, that is the concept given here. So, while dividing the rolling resistance with weight, it should be always the dynamic weight in case of a tractor, not in case of a single wheel. Then we'll try the concept of power delivery efficiency and tractive efficiency. That will be described using one more question. The thrust slip characteristics of each of the two rear wheels in a two-wheel drive tractor is given by F is equal to 34 into 1 minus e to the power minus 0.06 s, where F is the thrust in kilonewton and S is the slip in percent. Now, if the PTO power of a tractor is 30 kilowatt, calculate the tractive efficiency and power delivery efficiency of the tractor at a wheel slip of 15%. For each rear wheel and with a total motion resistance of the tractor has 2.4 kilonewton. Some more information has been given like efficiency of transmission between engine and PTO, between engine and rear axle is 88%, 82% respectively. So first thing when we are going to calculate the tractive efficiency is, in case of a tractive efficiency, we require to find out the drawbar power by axle power. So to find out drawbar power, you need to know the thrust value. Then deducting the rolling resistance, we will find out pull. So drawbar power is nothing but P into VA. Axle power is nothing but thrust into VT. VA is the actual velocity, VT is the theoretical velocity. So I can write this as P by T into 1 minus S. So now our aim will be to find out P, to find out T. So to find out T, I have an equation is given. Thrust is equal to, so F is equal to 34 into 1 minus e to the power minus 0.06 s. Now better I should write F here, because thrust is indicated as F is equal to 34. So I am replacing this T with thrust. Now slip is 15% given. Now substitute here slip as 15% directly. So you will get a value of thrust. Thrust value is coming as 20.17 kilonewton. This is for one wheel. Now for two wheels, there are two wheels in the rear axle. So you have to multiply with the 2 to find out the total thrust. Now total rolling resistance is given as 2.4 kilonewton. So thrust minus rolling resistance will give you total pull. Okay. Now pull divided, so you got the thrust value from this and rolling resistance value is given. So you can find out pull. Now pull divided by thrust into 1 minus S, that will give you directly the tractive efficiency. One part is over. So here you don't have to calculate this V and VT, because very simply I have converted into slip value and the slip value is given, so immediately you can calculate. You don't have to calculate the theoretical velocity, actual velocity. Some must be wondering, nothing is given, how do I calculate? So you don't have to worry, because this can be converted to slip. So that's why it becomes simpler. Now coming to the second component, which is the power delivery efficiency. So we know that power delivery efficiency is nothing but drawbar power by engine power. This is the ratio of two powers. Now, how much of the engine power is converted to drawbar power? That is the aim of giving this performance parameter, power delivery efficiency. Now, in this case, drawbar power is P into VA. So, we do not have VA value. So, what we will do? Drawbar power by axial power into axial power by engine power. So, drawbar power by axial power is nothing but your tractive efficiency, which I have already calculated. So, I can write this as tractive efficiency into axial power by engine power. Okay. So, tractive efficiency you have calculated, axial power is not given, PTO power is given. So, PTO power to engine power is given as 0.88 and then axial power to engine power is given as 0.82. So, axial power engine power is nothing but, so I can write this as axial power divided by engine power is nothing but your PTO power divided by transmission efficiency, which is given as 0.88. So, that will give you engine power. Now, engine power to axial power is given as 0.82. So, this ratio now becomes 0.82. So, it is a product of tractive efficiency which I have calculated. Now, axial power by engine power I have converted into PTO power by 0.88. So, that becomes 0.82. Now, tractive efficiency into that 0.82, that will give you the power delivery efficiency. If you want to express in percentage, multiply with 100, that will give you directly the percentage. So, let me explain this one again. This is drawbar power. Power delivery efficiency is nothing but drawbar power by engine power, and drawbar power I have divided axial power and then multiplied with axial power so that the ratio remains same. Now, drawbar power by axial power is nothing but your tractive efficiency, which we have already calculated, and the axial power to engine power directly it is given as 0.82. You don't have to convert to PTO power. Directly the power is given, ratio is 0.82. So, tractive efficiency into 0.82 directly if you multiply, that will give you the power delivery efficiency. Then multiply with 100, so that will give you percentage. So, this gives you, this problem gives you the where you have utilized the concept how to calculate tractive efficiency, how to calculate power delivery efficiency. So, all the concepts which you covered from lecture 1 to 4 has been, they have been used in these problems, 4 problems which you solved. I hope that will give you more use of these performance parameters, more use of these concepts, that will clarify little more, so that in future you may not be in a position, you should not confuse actually in future. So in brief, we can say I have given 4 problems. Out of these 4 problems, each one is related to 2-3 concepts, and all these concepts I have given. You can try, so that will help you in better understanding the performance parameters. So, you can solve some of the problems which are available in some of the books which are given here. So, that will further increase your ability to solve the problems. These are the books which you can follow. Thank you.